For our International Women's Day challenge, we were looking at the Bechdel test. So if we look at the web scrape data that we brought in, you'll see that it is very much difficult to understand at this moment in time. Apologies. If I click there, then you can see if I try and extend this field over a little bit, then we've just basically got a lot of HTML in here. So we need to parse that information out. So the way that I chose to do it was to split initially on sort of the greater than sign. So if I open that up to make it a bit bigger, this sign here, that's how I chose to do my split. And as you can see, we get about 60 fields or so from there, 58 fields from that. So maybe that wasn't the best choice. Let me know what you thought was a better way to split the data up. And then I got rid of all those that just contained HTML rather than the fields that we were interested in. So we're left with basically this field here, which tells us about whether the film passes or fails the Bechdel test and the information about it. So whether, for example, if I'm hovering over here, it tells me that there are fewer than 2 women in this movie. Okay, and then I get all the film titles here as well. It looks like each of them is followed by a little closing tag of the HTML as well with the letter A, so I need to remove that from there as well. So let's just do that in this movie title clean. So we're replacing the closing tag with nothing in that data there. Now we have this movie field. So you can see straight away, for example, this film that's supposed to just be called apostrophe 21, 71, sorry, that we've got this HTML code there for the apostrophe or the quotation mark. So we need to sort that out. Basically, we need to do that replacement. Now we did have the permission with this challenge that we were going to first of all replace all the and signs. So we're going to replace this HTML code here, this AMP, with the actual and symbol to help with one specific film. But for all of the other ones, we're going to want to find, first of all, those HTML codes and bring them out of this field, and then we're going to want to join it on. So I used some regex for this. So saying we want to extract basically anything that starts with an and then has some characters or so numeric or letter characters and also the hash sign, so one or more of those, and closing with a semicolon. So that's how we get out the first occurrence of that, and you'll notice we're using the regex extract nth. So as we build this up, so then in order to get out the second version, I'm not sure if this is the most efficient regex, but this is the version that I chose to use. So we've basically got that same capture group that we had before, but then a dot star question mark and oops, and then that same capture group repeated again, and we want to take the second occurrence of it. So we just need to make sure that we're adding as many capture groups as versions that we want to extract there, and it all the way up to 5. So if you see the 5th one, then you'll see there's 5 of those capture groups with dot star question marks in between, and we're just making sure we're extracting the 5th. I also did a 6th, but that field returned entirely null, and if we look at this 5th film here, then we see that it only has 5 of those codes within it. Okay, so now we need to think about our HTML input. So we just have the character that it's referring to, the numeric and the named code, because we have both types in our dataset. And then this just tells us a little bit about it with the description there. So we had that information as well to make sure that if in the description it contains the word space, then just return a space, otherwise leave it as that character. So we can see if I click on those values that needed the space, the description is space and non-breaking space. Okay, so then we pivot this so that we have our numeric and named code in one field. So that just makes the joining easier. We aggregate to make sure that we get rid of any duplication there. And then we just want to filter to remove the nulls and just do a little bit of renaming before we join it onto each of those HTML fields. So HTML1, we join that on, and each time you can see that it's just the nulls that are getting excluded, so we do a left join to keep those in. So those are the films that don't have these HTML codes in them at all. And then if you see, I'm just rename this character field to character1 and getting rid of the HTML field in each of these joins. I do that 5 times in a row. I'd love to know if anyone thought of anything more efficient. I did think about pivoting, but I thought that that would make it more complicated to join it all back together later. So let me know. And then again, for these 5 different HTML fields, we're taking our movie field and we're saying if it's not null, so if there is an HTML character to be replaced, then we use the replace movie HTML1 character1 else movie, and we can see how, for example, if I look at this stage at my first HTML character, then you can see that in, for example, don't look up is a simple one to look at. So before it was looking like it had a character, this code in between the N and the T, now it has the apostrophe there to replace it. So that's working how we want it to, which is great. Okay, so we do all that, those replace calculations 5 times. So each time just replacing it with HTML5 this time, for example. And then remove all those unnecessary fields. And by the end of this, we're finally ready to start looking at our other field here, which has our information about the Bechdel test in it. So I chose to split these up. I think I chose to split it up by the square bracket so that we got our 3 fields here. So, yep, 3 fields, sorry. Is that even right? No, I think that we got more. We got 4 fields, sorry. So our first of these contains the no pass or pass, and doing an automatic split on that. So when we go to split values, automatic there, that brings out our pass no pass, which is great. That's nice and easy for us to extract that information. And then you can see that already in our 4, we just need to then remove the other square bracket. And I split this off as well by using a split on that other square bracket. And then by the time we've done those splits and done some renaming, then you can see that what we have is our pass-fail field and our categorization field. So that's great. So it came out as pass or no pass. I just renamed these by double-clicking in those values to rename them to be pass-fail instead. So that's our data all cleaned up. Well, for now, we can see that a lot of these films have multiple values to them. They're not all unique films. So if I click, for example, on Anna Karenina, then I can see that there are different years, so that makes sense for there to be multiple rows for that film. But if I find something like Moana, so if I find Moana, it's got the same year associated with it, and you can see it both passes and fails. And we can see that there's argument as to whether there are more than 2 women in this movie but they don't talk to each other, or whether there are more than 2 women in this movie and they talk to each other about something other than a man. So does it pass, does it fail? As per this challenge requirement, we're going to be skeptical, and we're going to say that if it doesn't pass categorically, unequivocally, we're going to count the lower ranking. So, but anyway, first of all, we make sure that it's nothing to do with just the movie and the year being duplicated. So we do an aggregate, quick aggregate here, and that does reduce the row count a little, I think. Yeah, so it goes from, we get rid of 3 of those rows. Now comes our ranking. So we're just replacing this categorization. I just duplicated this field and then double clicked in it to change the ranking here. So just replace that with a 1, a 2, a 3, so on and so forth. So we get our ranking field, and then change the data type to numeric. Okay, so now to come on to that part where we're going to be skeptical and make sure that we only have 1 row per film. So we're finding those duplicates, so we're using a fixed LOD for that. So we're grouping by the movie and the year, and we're counting the distinct categorization that they have. So we can see that some of these have 2 different categorizations, and so we're going to filter to just those duplicates, and then we're going to take the maximum ranking in each of those cases. Join that back to our data set on the ranking, the movie and the year, So we could just get six of those 6 films being returned. And then over here from our duplicates stage, we can just filter to just the single rows and get rid of that extra field before unioning that back in. And we have all of our 9,408 rows now, all being unique with their rankings for whether or not they pass or fail the Bechdel test. And isn't it interesting that 50% of these movies on the list pass the Bechdel test outright, which doesn't seem that high. Maybe it seems higher than you were expecting, but obviously this is just a list that is being compiled by people on the internet, so it's not every film in there at all. And as you've seen as well, there's clearly debate about those films that are on there too. But hopefully you enjoyed this, and I'd love to see some visualizations created from this dataset if you're interested. But thanks again for taking part in the challenge, and I hope this was useful.